Hi, pre-calc. I'm going to now graph, let me get this to focus. I'm going to now graph the cosecant and the secant. If you're going to graph the cosecant, you first have to use its reciprocal function, which is the sine. The table for the sine, the standard table, is gotten off of the unit circle. So you're going to do the pi over 2 increments around the unit circle, all the quadrantal angles. And I'm just getting these values off of the unit circle. Okay, so that is the standard table for sine. So when you draw the cosecant, you first want to draw its reciprocal function, which is the sine. So I'll start by drawing that. I haven't modified it at all. So I'll just give you the most basic cosecant before we do anything to it. Let's see if this is 3 over 2 or 1.5. Then 1 is 2/3 of that. Okay. So this table that I just drew, I'm going to just work off of it now. So you have the point 0, 0. You have the point pi over 2, 1. You have the point pi and 0. 3 pi over 2, negative 1. 2 pi, 0. Now I'll connect the dots. And now I'm going to just stretch out the graph. This is the sine function. Middle, up, middle, down, middle, down, middle, up. Okay, so what I did there is I just pulled out the sine function. So the graph in the black is a sine function. Okay, this is how you handle it next. The cosecant function is the reciprocal of the sine function, right? So they're inversely proportional, right? They're opposites. If the sine is small, the cosecant is big. If the sine is big, the cosecant is small. They're inversely related. The first thing I want you to notice is that for the cosecant function, if the sine of x equals to 0, right? If the denominator equals to 0, if you have 1 over 0, that's where the vertical asymptotes occur. Okay, that's where the vertical asymptotes occur. So when this denominator is going to be 0, that's where your vertical asymptotes are. So I'm going to come over here, and everywhere that the sine is 0, I'm going to create my vertical asymptotes. Now, if the sine function is moved up or down, the vertical asymptotes will always occur in the middle point, in the center point. Because you always have a high point, a low point, and a middle point. And the VAs always go through the middle point. So if you move the graph up, the middle point goes up. So don't assume it's always through the x-axis is what I'm saying. Don't assume that the VAs always go through the x-axis. They always go through the middle point. Not the high, not the low, the middle guy. Alright, that's the first thing. So that's where my vertical asymptotes are, where the sine is equal to 0. The next thing I want you to recognize is that when when the sine is equal to 1, or when the sine is equal to -1, the cosecant is also equal to those values. I'm going to say that one more time. When the sine equals to, at angles, when the sine equals to 1, the cosecant also equals to 1. At angles where the sine equals to -1, the cosecant is also -1. So what I'm saying is, at all the hills and valleys, these two functions touch. These two functions will touch at all the hills and valleys. And then after that, they are inversely proportional, meaning as one goes smaller, the other one goes larger. Okay, so the floating parabolas are actually the cosecant function, and if I had drawn the original function in, I'm just trying to open a whiteout here. If I had drawn the original function in pencil, I could have then erased the original lines that I used for guidance. I could have taken them away if I had done this in pencil. Right, I could have gotten rid of this because I only used the sine function as a guide. Right, so I could then take away the original if I had used pencil, which is actually a nice thing to do on test 3. If you use pencil, you take away the original function because the cosecant are just these floating parabolas. All right, so let's make some observations. One cycle, or one period, of the cosecant is a parabola up and a parabola down. So in between 0 and 2 pi, one parabola up, one parabola down, that's considered one cycle. Because after that, the pattern just repeats. It goes up, it goes down, it goes up, it goes down. So that's one cycle. What the sine function does, it does two things, okay? The first thing it does is it tells you how wide the parabola is, because we can figure out where the asymptotes are based on the sine function. So the sine function tells how wide it is and pushed off how far is it pushed off from the axis or from each other. How far away are they technically from each other in an up-down perspective. Okay, gang, I will do another one of these, but I hope that was a good start. I hope you're seeing the graph. Catch you again soon. Bye-bye.